One of the central stories, one of the kind of important stories that they like you to ask, like you to be able to describe, tell the story of how it is that, what is our modern theory of enzyme action or enzyme activity? In other words, how do enzymes work? What's our understanding of, what's going on with enzymes that make them work? Bear in mind, right? And I should have said this already. One of the key things about catalysts, about enzymes, but about catalysts in general, is that they remain unchanged at the end of the reaction, right? So they take part in the reaction, but at the end of the reaction, the enzyme is there, the catalyst is there in exactly the same form and exactly the same amount as it was at the beginning of the reaction, right? But what that doesn't kind of tell us is that it does get changed. It is involved and does change during the reaction. It's just that it changes and then changes back again into the original format that it was in as the enzyme at the start of the reaction. So let's see how that works. So at the very beginning of the story, you have the enzyme and a part of the enzyme that the substrate will bind to, and the part of the enzyme where the catalysis happens, like the change to the substrate, that part of the enzyme is called the active site. Okay, so the active site of the enzyme is that part of the enzyme to which the substrate binds and where the substrate is converted into products by the enzyme. Okay, so in order to change the substrate, the enzyme must bind to it first of all, and it binds at the active site. Now, what you might not notice from the picture unless you look closely is that the shape of the active site is not exactly the shape of the substrate when the enzyme is nowhere near a substrate. Okay, it might look similar, but it's not in any way, and it doesn't have to even be similar. It could be wildly different. But what occurs during an enzyme reaction is that as the substrate moves closer and closer to the active site, the proximity, the closeness of the enzyme and the substrate causes a change in shape of the enzyme's active site. Okay, so let's just think about that again. As the substrate gets closer and closer to the active site, it causes a change. There's a kind of an interaction between the substrate and the active site, causing the active site to change shape slightly in order to better fit the substrate, right? So the shape of the active site changes so that it fits the substrate really well. Okay, so that there's a really good fit and a really tight bind between the two of them. Now, what we get then when that binding happens, when the substrate binds to the active site, we call that the enzyme substrate complex, and you need to know those words. Okay, so on any sort of question we're asked you to describe, the theory of enzyme action, or describe how it is that enzymes act on the substrate in detail. You want to draw this kind of picture, you want to fully label it, but you want to mention in your description, because a label diagram is never enough for a description question. It's always a good idea to put a diagram in there, but you've also got to tell your story. So you should have enzyme substrate complex as part of your description. So once the enzyme substrate complex has been formed, then the catalysis happens, right? Then the enzyme is able to do its job by turning the substrate into products. And so you could call that enzyme's product complex. That's not necessary, but that's what it is. And then you get release of the products once they've been formed, and the active site returns to its native shape that it normally has. Okay, so then that means that at the beginning and the end of the story, the enzyme is exactly the same shape, same everything, same properties, same everything. Okay, so that's the induced fit model, and the reason it's called induced fit is because the shape of the active site is induced it's changed, right? It's induced to fit the shape of the substrate. Okay, so it's induced to fit the change, the shape of the substrate.